Okay class, so today we're going to be working with fractions, and I have a word problem for you here on the board, but before I start that, we're going to look at defining what a fraction is. And so we know a fraction is a part of a whole. And so the way we represent this a lot is by using unit fractions, and that is represented by 1 over b. And when we look at that, that just means that a whole has been divided into b equal sized pieces. So a fraction, whenever we divide it, all the pieces are always divided into equal sizes. So to give an example of what a unit fraction would look like, if we have a whole that looks like this, and we split it up into 4 equal sized pieces, 1 out of those 4 pieces would be a unit fraction, because we're having 1, and then this is our equal sized pieces, so that would be 4. And so we can show fraction values in a couple of ways. There's 3 different models we can use. We can use linear, area, or the set model to solve problems. And the part is going to depend on how we define the whole. So that's going to be a little different for each problem. So before we jump into this problem, this would be appropriate for probably 4th grade, because that's when they start using representing and generating fractions to solve problems. So our word problem today is Anna has 5 coloring books, Jack has 4, and Sam has 3 coloring books. What fraction of the coloring books does Jack have? So we're trying to figure out what part of the total number of coloring books Jack owns. So we're going to start this by using the set model. And in the set model, we use a set of objects. And our part is the portion of those, how many sets of those objects that we're going to shade in. So we're going to use counters for this, but first let's find out how many coloring books they have all together. So we're going to add, we said Anna has 5, so we're going to add 5. Jack has 4, so we'll add 4, and then we said that Sam has 3 coloring books. So we know 5 plus 4 is 9, plus 3, for a total of 12 coloring books if they put theirs all together. So in this problem, some students might think this is the whole, but this is actually, we're going to split our sets into it. So our number of sets is going to be our whole, which will be our denominator in our fraction. So I'll draw this on the board, and I'm also going to use counters. And I'm going to count out 12, 2, 4, 5, 6, 7, 8, 9, 10, 11, and 12. And I have them all flipped to the same color, so you can see this is our whole group right now. This is how many we have total. And I'm going to go ahead and look at my problem again, and I'm looking for Jack's coloring book. So it says that Jack has 4. So I'm going to go ahead and flip 4 to the red side, so I can differentiate between what's Jack's and what goes with the rest of it. So now I want to make a set. I've already made one set of 4, so I'm going to see if I can make another equal set of 4 if I have enough. But we're going to keep these yellow because they're not representing Jack's. So I see that I can make another set of 4, and I have exactly 4 left. So as you can see, like we said with the fraction, you split it into equal sized pieces, so I've split mine into 3 sets that each have 4, so equal. And I'm going to draw these on the board too. So this represents Jack's, and that is one set. That's set number 2. And we have a total of 3 sets. So in the set model, since we're looking at our whole as the number of sets, our denominator is going to be 3. And we can see that shaded, or on the counters are red, we have one set that is Jack's. So Jack has 1/3 of the coloring books from the group. So that's the way we solve that with the set model, and next we're going to look at it using the area model, and you could do this on graph paper, or we're going to look at it 2 different ways, and I'll draw it for you on the board. So in the area model, we're looking at a whole, and that's going to be shown as a region or a certain area, and then the part's going to be the area within that we have shaded. So this is going to be our whole, and we're working on the same problem. So I have these little pieces right here, and this is I have 12 of them. So if you split this into 12 equal sized pieces, we would put these blue on top of here, because we know that our total number, oh, I erased it, but our total number of coloring books is 12. And since we said, can't do this, that Jack has 4 of these, there we go. So that's one way we could look at it, divided into 12. And then another way you could look at it is using graph paper, or I'm just going to draw it on the board. Here we have our region, and I'm going to make 12 equal-sized boxes. And so you can see we have 12 boxes here, so again, like our total number of coloring books. And we said that Jack has 4. So looking back at our unit fractions, to represent that on this, we would have 1/12, because we have 12 equal-sized pieces, and one part of that would be 1/12. So we said that Jack has 4 coloring books. So we've already shaded in one. We're going to shade in another. He has 2, 3, and 4. So we can see that we have 4 shaded in out of 12. So in this area here, we said our total area was 12 boxes, and he has 4 shaded in. And so looking at this looks a little different than the first fraction we found. So we're going to talk about equivalent fractions a little bit. And we're going to look at, we said the answer for the same problem was 1/3. So a way we can figure out if that's going to equal the same as 4/12 is we're going to try multiplying the top and the bottom both by 4.
Okay, I'm going to stop you real quick. Think about what we learned today. How would you do that instead of going to the algorithm?
Oh, show it on here.
Mm-hmm.
Okay, you want me to just go back then?
Mm-hmm.
Okay. All right, well.
Because you were talking about 1/3.
Yeah, no, that makes sense.
So now
Yeah.
show how.
Okay, so we said in our in the last way we saw this with the set model that the answer was 1/3. So we want to check if that's equal to 4/12, if they're equivalent. So we could look at this right here, and I remember we divided our sets, still on the table right there, into 3 sets of 4. So I'm going to see if we can section these off into groups of 4 boxes. So there's one right there. Actually, I can use yellow. So there's one right there, one set of 4. And we can make another box with an area of 4. So these both have an area of 4. And then we can make one more. And so we can see that we have 1, 2, and 3 equal-sized areas of 4, and one of them is shaded in. So we know that 4/12 is equal to 1/3.
Okay, because each one of those sections is what? What unit is that?
1/3.
Mm-hmm. So show that.
Okay.
That's 1/3. That's 1/3. Very good. Mm-hmm.
And that is how we would solve our word problem using the set model and the area model.